It is the allotted time, and we're starting a, a teleconference call with Peter, who can't be with us in person, but will be telling us all about. We'll make some mention of their recent celebrations of 50 years. So I don't know. Over to Peter.
Yeah, thank you very much. I hope you can hear me.
Yes, I'm hearing you very nicely. Thank you.
That's perfect. So, yeah, you see, this is not a recording. We are in a live session. So, yeah, welcome everyone, and thanks for having me. Yeah, it's. I think there will be some excitement guaranteed today. I guess mainly after my presentation, when everyone is going to look, hopefully, for the successful Starship launch. Well, in my presentation, I want to give a short flashback to the 50 years we celebrated actually last year. And yeah, I would like to focus, maybe not everyone is aware what AMSAT groups worldwide are doing. And AMSAT North America was indeed founded before AMSAT-DL was founded in 1973. I think AMSAT-UK is also soon going to celebrate 50 years. I think I would like to put the focus also on what actually AMSAT is. So we are practically a non-profit, non-commercial organization. We are even charitable. And all what we are doing is voluntary work. That means nobody of the traditional, let's say, of the AMSAT organization, like AMSAT in North America, AMSAT UK, AMSAT HB, AMSAT France, and others as well. So we are run by volunteers. That means we are not paid in any way for the things we are doing. We are not doing this commercially. And I think that is important to understand. Basically, we do everything in our free time. Usually we get compensation for projects when we have to do some trips or something like that. So usually those costs are compensated, but we are in no way paid in any way for the things we are doing, for the things we are flying or anything like that. So we completely depend on donations, on support, like AMSAT-DL. Now and then we get support from the DLR, for example, if we have an interesting project for them. But that money is always only spent on material, launch costs, and things like that. I think that is important to understand. And also, like AMSAT-UK, AMSAT North America, AMSAT-DL is a registered organization. That means we have an elected board of directors, which are elected by our membership. So, let me see how it switched. Yeah. So if we look back, it's quite a history, starting with Sputnik in 1957, which was not an amateur radio satellite, but which was in practice received by many radio amateurs, and actually the radio amateurs were even the first one to get it. Even in Bochum, Professor Kaminski, the founder of the Sternwarte Bochum, was one of the first to receive Sputnik 1, and that actually made everything possible what we are doing here as an AMSAT community. So we have Oscar 1 in 1961, and indeed very interesting Oscar 7, which is still alive after so many years. Then as an AMSAT-DL group, we were, and AMSAT-DL already was founded, as I said, in 73. Some of the transponders built for Oscar 7 were done by AMSAT-DL. And if you look at AMSAT-DL projects, we have the famous Phase 3A satellites, Oscar 10, Oscar 13, indeed Oscar 40. Then we were in around 2004, we were looking to go to Mars. And finally, in 2018, we got the first geostationary amateur transponder, or a kind of hosted payload on the SHAL-2 satellite from Qatar. And now it's almost 25. The year he has a reason, we will see later on. We are going to build some small satellites, our Arminas mission, which is going to be launched with Rocket Factory 1 rocket in next year. So Martin showed this graphic already yesterday, showing how many satellites were launched. And yeah, you see it's going exponentially up. We even have about 100 Oscars or even more now in orbit. Most of them are with, as soon as they got an Oscar number, then it is clarified that they really contain an amateur radio payload, something like a transponder. So not all of the CubeSats launched or satellites launched in the last couple of years are amateur radio satellite. Also, they are using amateur radio frequency. So sometimes we have to look at that. But fortunately, we also have the IAU frequency coordination, which is taking care. Yeah, so a lot of amateur radio satellites have been launched, as I said. Not all of them are amateur radio. Not all of them are from AMSAT groups, and they are still qualify as an Oscar. For example, satellites from universities, educational institutions, and so on. But sometimes we are also seeing problems with commercial use of our frequencies, and not all satellites using our amateur radio bands are actually satellites carrying amateur radio. Also, they use the frequencies, and most recently there is a constellation of satellites in orbit called Bluebird 1 to 5. These satellites use amateur frequencies, but they are strictly commercial. It's a little kind of a problem. I have extracted here the FCC paper about it, and what is really interesting to see is that they use the entire amateur band from 430 to 440 megahertz for their commercial LEOP operation of their satellites, in particular outside of the United States. So that is a very interesting thing. The FCC granted a license for AST to operate these satellites in our bands, but only outside of US. So that is rather strange. So there are a couple of ground stations in Argentina, Australia, Bulgaria, St. Helena, in South Korea. The satellites are operating so they transmit and receive on the same frequency with a 50 kilohertz bandwidth, as I say, practically in the whole 430 to 440 megahertz amateur band. Very interesting here is to note that even the FCC confessed that there is no relevant service classification for those satellites to operate in this band, because this band is mainly for amateur satellites for other purposes like radio location, Earth exploration, and things like that. It is not primarily for commercial use and not for the things AST is doing. So the problem here is there was already a first example, which was Blue Walker 3, which was received by many radio amateurs. But even that one was a kind of strange that they used those frequencies. So what happened? AST submitted an interference analysis to the FCC in which they demonstrate that there will be no harmful interference to other operations in conformance with the ITU regulation. So although the satellite is not supposed to be there, they demonstrated that there is no harmful interference because nobody complained about it. So that is what I would like to put your attention in. If you see things like that, if we don't react, and you know there will be a lot of constellations going up and they are very frequency hungry, we might lose our bands. So please be careful, talk to your amateur radio organization, because it's not only the satellite band affected, it's the whole amateur radio band affected. So please talk to your organizations and take care that this is not going to be the predecessor of more to come. Anyway, in my presentation today, I would like to focus on a few things. So as you have seen, Oscar 10 was launched 41 years ago. It failed after 3.5 years because the memory died, so the computer is not working. The interesting thing is, at that time, 40 years ago, space debris mitigation and things like that were not so much in the focus. Even nowadays, every satellite needs to have a mechanism so that when the satellite fails, it will on no way continue to emit RF signals. Oscar 10 was actually operating still a few times, but then pieced because more of the electronic failed, probably battery or something like that. And for the last 20 years, I think nobody tried to see if it could be reactivated. But for a little while, it was still transmitting a carrier, which was quite interesting. Oscar 40 is also still in orbit. It was launched 24 years ago, but it failed 4 years after the launch due to a short circuit in the main battery. And by design, there is no way that Oscar 40 will start to transmit from alone. It's a more complicated process. So while there is a chance that Oscar 10, like Oscar 7, might still transmit, Oscar 40 will never start to transmit from alone. So in some way, you need to send some commands to the IHU. Why I'm talking about this? Because, already a couple of years ago, there have been interests expressed by people, could we not try again, like with some of the other satellites, to start a kind of reboot project. So a couple of days ago, I digged out all my old IHU simulator, and even though I didn't use it for the last 20 years, it's still working. And at the moment, we are getting all the things back together, even the old command station stuff, the old software. Some of it is only running on RISC PCs, so even the old Windows software, it's not really running on Windows 11 or Windows 10 anymore, but we have our IPS set up, so we are going to try again. And well, some of the old team is in some way was burnt out, but we have new people active, in particular with the Aminas project, who saw all the remains in our store and said, wow, what really cool things you have done almost 30 years ago, and they want to dig into it. They want to understand and learn, and maybe in one way this could be also reused in future projects, because there's a lot of technology, mostly indeed the architecture behind, which could be very interesting still to look at it. Yeah, and if we talk another satellite, that is Oscar 100 on SHale-2, the first geostationary amateur radio transponder. Unbelievable, it's already 6 years in orbit. It's even strange to me how quick the time is running. Yeah, I guess if we get older, time is running quicker, but it's already 6 years in orbit. It still works perfectly. There is no sign of degradation, and so we are very hopeful that the projected time scale of 15 years will be fulfilled. Remember, in 2018, launched with Falcon 9 from Florida. there are not many pictures existing from the satellite itself. So the picture right, that is the so-called Melco DS2000 platform used for the satellite. That is a picture which are found in the cantina of SHILSAT in Qatar. It's the only real picture existing. The other one was here when it was launched and the separation. And indeed, actually only one picture during the early times when SHIL2 was built. Yeah, since 2020, we are having Antarctica via Q100. So several expeditions started to use it. The first one indeed was in 2020 with Roman HB9HCF. He was the first operator of DP0GVN during the overwintering. And indeed, the antenna is specially made under radome to survive the harsh temperatures and the extreme winds. In fact, a couple of years later, we had to replace the antenna because during a really severe storm, the antenna was blown away. But it is very popular. Here's one example with a group of students, school kids in a school. Matthias DB2OS organized this school contact with Antarctica, which is still very popular. Unfortunately, there is a technical problem at the moment. We are sending a replacement unit down to Antarctica because they can't receive any signals from the spacecraft. Most likely the LNB for receive is damaged, broken. They had a replacement unit down there. We shipped one, but unfortunately they couldn't find it. So we have to ship another one. Also in 2022, we started to use Polarstern, the German research vessel, the icebreaker, which is going around not only to Antarctica, but also in Arctica and even across. So there have been a lot of very cool contacts from the ship over Q100. And here on the left, that was the first activation by Felix and Teresa, who tried if it will work at all. They had manually steered that dish. And the good results we found, we built another antenna where we got this radome and the parts of the antenna sponsored, because this antenna is automatically tracking Q100, because sometimes the weather could be very severe, so manual steering is not possible. And this is what I like so much, and in fact, I would like to be there as well. Portable operation via Q100 is really popular. Here are two examples from Hugo and Paolo, who operated Q100 from really very nice remote locations, and it's really fun. And at that times when they are active, the band is full. Sometimes the transponder is a little bit empty. There could be some more activity, but this definitely helps. So what else? Since 2003, we heavily use the Bochum Observatory. We are very fortunate to have this 20-meter radio antenna available to AMSAT. In fact, the dish was already inaugurated in 1965. It was used for some of the Apollo missions. Apollo 11, it was used as a backup station. There are recordings of the real communication from the moon to Earth. Then in the years to come, the antenna had some problems and needed some refurbishment. And in fact, the only reason why the antenna is still there, because AMSAT-DL practically got into this refurbished, upgraded hardware and software. And in 2003, Mars Express was the first spacecraft we received with further distance. So in the past, indeed, in 1965, there were no Mars missions, and after it, so that was the first time that we really received such a deep space interplanetary mission. From there on, we have done a lot of very exciting stuff, like receiving Voyager 1. So that was a new record, and it was the first non-government receiving of Voyager 1 from a kind of private organization as we are, as AMSAT. And in fact, we sent a QSL card, which is seen here, to Pasadena to the Voyager flight team. And I have a later picture. You will see it's still on the wall there. Also, Venus Echoes in 2009 were quite interesting, where with really high power, the signal was sent on 2.4 gigahertz to Venus, and 5 minutes later we received the echo from Venus, and that was indeed the first one in the farthest ever amateur radio contact world record. So we had a special license because we are using 5 kilowatts of power with the high gain 20-meter antenna. Speaking about all those missions, yeah, sometimes I have been asked how many missions did we actually receive. I have a rough number, but sometimes I have, like in your photo book, when you are traveling and you want to see, oh, where I have been in all those years and places. I keep more or less a log on nowadays on Twitter, where we put photos of the missions and signals we have received. So basically there's everything indeed. Most recently ESA, JUICE, Hera. We were also taking part in this IPSAT project, where these images were transmitted from the first Ariane 6. They were transmitted on S-band, and we received them with a 20-meter antenna in Bochum, completely remotely. That means me sitting at home, controlling the 220 tons heavy antenna in Bochum completely by remote. Also interesting was here that is a main control room in the ESOC control center in Darmstadt, and they had actually our web stream also on one of their screens here. So practically, it's the other way around. Is there any interplanetary probe we didn't receive? So I'm going through those pages here just a little bit more quickly. So we have received Chandra 6 around the moon. We have followed several moon missions like the intuitive machines IM-1. A lot of interesting stuff. And yeah, here's a picture I've said to you from the Voyager team. So here our QSL card is still on the wall. And indeed, Voyager is an absolutely amazing spacecraft and a fantastic team if you imagine how long and how far Voyager 1 is traveling over those years. So we did receive signals like from intuitive machines, which was falling over. And in fact, we were the first to demonstrate or show it hasn't stopped yet. It's still there. So it was a very weak signal. We were really, really looking with our dish and with our receive systems at the absolute limits of the receive sensitivity. And we could show IM-1 is still alive, very weak, but it's still alive. And practically our observations helped Gunhilly to optimize their antenna to finally regain contact with a spacecraft, and it operated for a couple of days. And so we got direct. So why that's actually also part of our outreach. Not only because all that is a lot of fun, but also to see that we get some support. And in fact, Intuitive Machines was really happy for the support we have given here. And you always learn a lot of things by this. The same thing we did for Hakuto-R, which landed on the moon, or which was supposed to land on the moon in last April. we have been following the signal, among others, and some people really looked into the carrier and fine grain of this kind of signals, so you could see the wobbling from the spin, but even very other interesting details could be seen. For example, like here with the SLIM, we could see reflections of the transmitted signal from the lunar surface, and all this information. People like Dani EA4GPZ, he looked really into the fine details, and there was a lot of things to learn. He has some very nice articles on his webpage if you want to understand more. So, like the SLIM Moonlander and other things, there is always a lot to learn about how signals propagate on the moon surface, Doppler shift, how can you calculate antenna appointment, and so on. And we were very glad also to have the Japanese amateur radio club at JAXA representative in Bochum 2 weeks ago. It was a symposium. So they were very happy about how we supported the project and what kind of signals we received and what we could learn from it. And indeed, all that helps for future missions. Like here on the left side, we also received this little hopper, the LEV 1. But there have been other missions like Peregrine from Astrobotic, which we received and where we had some very interesting and helpful information. There are more projects like ESA Cluster, UNO, Korean Pathfinder, very exciting stuff. And yeah, also I would like to mention here, in the past we had used different software. I think since last year we were mostly using the famous SATAM software from Alan, to mainly for our web stream, but also to decode some of the telemetry or record carriers for further analysis. Just for you to understand, we are not hacking or doing something illegal. Everything we do here is completely legal and actually part of our educational outreach mission as part of E0, the German E0 project, to really get people interested into this kind of things. So, in short words, we have received more or less over 40 interplanetary spacecraft has been tracked by us in Bochum, and mainly we are doing these things from remote, like me here sitting at home, controlling the big antenna and frequencies. Also, I do this almost daily with James Miller, G3RUH, who is very much taking care about the precise tracking, updating the tracking software and all the ephemeries we are needed if you want to track such a wide, far away object. And why is this so important? Well, look at the numbers here at X-band at 10 gigahertz. Our 3 dB beam width is only 0.1 degrees. And even on S-band, it is 0.4 degrees. So if you don't have precise tracking, you hear nothing. So that is very important to understand. So why we are doing these things, indeed, we wanted to do a couple of years ago our mission to the moon. That is still something, indeed, we hope one day to get to the moon, maybe as part of one of the landers mentioned before. We have some contacts with them. There is actually one lander this year who is very much appreciating what we are doing. And we have an NDA, so we will try to support them as much as possible. But the NDA does not exclude us to show the spectrum and other things on YouTube in real time. So that is very kind and very nice. And maybe one day we will have a chance to fly an amateur radio hosted payload on one of the landers in return. So, as I say, ham radio on Moon, Mars, and beyond, we have to think about it. How fast we will get there, we might see today, later on. But nevertheless, something we should always have a look, and there might be opportunities to bring amateur radio payload there. So from the biggest to the smallest, so the last real big spacecraft, AMSAT-DL, together with international AMSAT, with AMSAT-NA and AMSAT-UK and others, was indeed Oscar 40, which was a 650 kilogram heavy spacecraft into HEO. We are now going to the smallest AMSAT-DL ever did, which is a pocket cube, and which is the AMNIAS-1 mission. We will fly into LEO pretty soon. And yeah, if you compare the weight, 640 kilogram to 248 gram, it's really a big difference. So in 2022, actually, there was the micro launcher payload competition by the German agency, the DLR. And this is actually where the project was born. AMSAT-EA pushed us because they were the first one to see this opportunity. Sometimes you are in the same country and you don't know what's going on. So they were actually the ones saying, hey, there is this competition. Shall we not try to apply for it? And that's what we did. So together with LibreSpace, AMSAT Spain, also with support from ESERO Deutschland, we made the proposal, which we called Erminas, to be launched on one of those micro launchers. So what is Erminas? Erminas is a syndicated multi-pocket cube mission. We have our own pocket cube deployer, which was developed by LibreSpace, and it contains, theoretically, it can contain 8 pocket cubes. In our case, we have 7 pocket cubes. Why? Because 2 of the pocket cubes are 1.5 P standard. So the standard 1 PQ format is 50 by 50 by 50 millimeter with a mass of 250 gram. And these 2 are 1.5 PQ size. So that's why we ended up with 7 pocket cubes. So we will have 2 pocket cubes from AMSAT-DL. That will be AMINAS-1 and U and 1V. 1U operates in the 70 centimeter band and 1V will operate in the 2-meter band. Then we have the satellites from Spain, UNNE-1 and Maria G. They transmit on 70 centimeter, but they also have a transponder with 2-meter uplink and other nice experiments. Then there will be the Cubic 5 from LibreSpace, and also because LibreSpace delivered the deployer, we gave them the opportunity also to have 2 of their ZITLOC PQ1 and PQ2 satellites, which will be used for spacecraft identification and localization, project which is funded by ESA, and they are indeed not using amateur frequencies for that. So that is the basic design of a pocket cube, which is actually a standard design based on the cubic design from LibreSpace. So we had a very short time frame, so we had to look, okay, what can we do in this short time? Because we have a P3E sitting around, but it's too heavy and too big. So we were looking, okay, what can we do? And fortunately, the original design from LibreSpace is open source completely. That means open hardware and open software. We had to do some improvements. There were also a few things which were probably not in the documentation and had to be changed. We found that out, but mainly we're following here the cubic open source standard from LibreSpace. The only differences I marked here is that indeed typically they always use the 70 centimeter band. We will use the 2-meter band for the first time. So having a larger antenna, we will use micro SD card, which stores images. So we will transmit SSDV images and other information which is stored from the micro SD card. Unfortunately, there is not enough power, not enough room to really have a linear transponder, which we would really like to have, but it's the beginning. That is a basically short block diagram. So we have on 5 sides, we have solar panels, then we have charge management, power regulation system, a battery, and then some of the payloads. So here in red, I marked where we made some changes. We made some same changes on the receive and transmit part to adapt it to the 145 megahertz band because it was originally designed for 435. We have added a sensor board and we made some changes on the antenna. This is the AMINAS-1 sensor board. It will fly on both AMINAS-1U and AMINAS-1V. You have seen that probably yesterday already. We will also use a radiation sensor, this famous BG51, which you see here. It's the OEM version with no plastic cover and so on. In addition, we have a 9-axis IMU, which is practically triaxial accelerometer, a triaxial gyroscope, and magnetometer, 3-axis magnetometer, all in one case, which is this part here. Then we have additionally Bosch BME 280. We mainly use it as a very good temperature sensor, but actually it is also able to measure humidity and barometric pressure, which doesn't make sense in space indeed. But this board can also be used, for example, on balloons and other things. All the hardware, software developed by our team is also open source, and we have a GitHub repository where all this is stored. We made some optimizations on the antenna. So instead of this stretched dipole, we will use an angled V dipole because it gives a very much better antenna pattern. A straight stretched dipole has these very deep tips, and the problem here, it could be very problematic. If the rotation of the satellite is in some way synchronized with these deep dips here, it can happen that due to the ratio of frame length and rotation speed, it could be possible that we cannot communicate properly. So to improve this, we have made changes on the antenna, and indeed, we hope that this will give better signals too, something we still to be seen. Now, let me see if that works. For some reason not, so that is, I don't know why. It should actually run, but it doesn't. That's too bad, because I wanted to demonstrate how the antennas will undeploy, which is quite spectacular. But I don't know why this is not possible to play on this screen. It runs in my original presentation, but not on this screen. Sorry for that. Well, here's the AMINAS team. So we have a couple of people. Also, that was during one of our meetings in Bochum. We had Fabian Manoles from LibreSpace visiting us, and then indeed Tillmann, Nicole, myself, Patrick and Tillmann are the key persons here, and Thilo. So myself, I'm being the overall mission manager, and also the contact person with all the agencies regarding the overall missions, also with our partners from LibreSpace and AMSAT Spain. So Tilma and Patrick, they are actually the project managers in terms of hardware and software. We had Jens, he was building the first prototypes. Holger DB2OS, our RF and antenna expert, who actually looked into the design of the antenna, and a few more people working on this. So mission goals, indeed, can we do such a project with minimum budget and resources available? Remember, for this project, we had no external funding except for the ride with Rocket Factory, with a free ride, but all other costs involved, even getting the things to Saxoford, still costs money, which is basically coming from our membership. Indeed, another goal was creating a new team. Most of the people have never touched a real satellite before. Probably I'm the only one left over. I'm getting old. So also important to get all the know-how transferred and learning by doing. And sometimes it's easier to tell people what is right or not if you're doing it. So that's also kind of know-how transfer. Also, we are trying to get cooperations with partners, Sternwarte, Bochum, others. Indeed, we want to contribute to amateur radio, satellite community, with a satellite for everyone, basically. We want some kind to produce satellite kits for radio amateurs in schools to experiment with it. And indeed, we want to scale up for missions to come. We have built a small clean room under the radome in the Sternwarte, where we have the right environmental actually to work on such project. So here on top of this box, you see the airflow, laminar airflow and filtering, so that we really have good working conditions there. Indeed, there is a lot to be done. Vibration tests, shock tests, bake out. So test is very important if you want to have your spacecraft surviving. These were early tests with engineering models. After building the flight models, we did shake tests at the Universidad Politécnica de Madrid. We are very thankful for our partners from Hyra Space and AMSAT Spain, mainly here Pablo, Felix, Marina, which were very helpful to organize that we could really do these shake tests with our flight hardware and the deployer. And indeed, here we have Thanos, Andreas, and Elias from LibreSpace. And yeah, spacecraft was traveling a lot by train, by car, airplane, and now we are looking forward to launch with a rocket. So we have done all the final integration in August, a couple of weeks ago. We basically put everything together, flight ready, lots of happy faces, but then what happened? As I told you, we are going to launch with Rocket Factory 1 on their rocket, and here on the right you see the UK spaceport in Saxoford. That is where we are going to launch. In a couple of weeks ago, actually that was one day before we did our integration, there was supposed to be the hot fire static test of the first stage. Unfortunately, that stage, well, was blown away. There was spectacular fireworks, not what we expected. There was an anomaly which practically destroyed the first rocket stage, which was supposed to launch us later into space. So that was a kind of shock, but on the other hand, these kind of things happen, and better now than later. I can tell that Rocket Factory was very transparent here. Already the next day, they called me and we had a discussion where they explained what happened. They felt very sorry about it, but my reaction was actually no, not to be sorry. That is something, if you have a new rocket, these kind of things happen. We experienced that in the past. Even SpaceX Falcon 1 was only successfully on the fourth launch. So as earlier we find these kind of problems, there is a better chance that we will hopefully get a successful launch. I see I only need 5 minutes, so don't worry. So the lessons we learned, no matter how big or small your satellite is, the administrational work is the same, even like building a big one. Um, I'm saying this because it's not only about building a satellite. You have a lot of contacts. Indeed, you have the launch contract and all the related documents. You have to make space debris analysis. That is what we do with DLR. Then you have to do with Bundesnetzagentur, that is something like the Ofcom in UK, the the governmental organization which takes care about frequency assignments, ITU, IAU, so that you get all that stuff. And also we have to, because we are launching from a British soil, we have to work with the UK Civil Aviation Authority, the CAA, and there is a huge amount of documentation. Practically, this is a job for one person, a full-time job, and I had to do that in my free time after work. So because I have a real job, never forget that. So there are a lot of things, and that is something also David and my friends from AMSAT-UK will run through it. The first step is to get this green or yellow in this ample light, but then the real work begins because you have to provide a huge amount of papers regarding national security, national interest, international obligations, fit and proper persons. That means, am I personally a proper person to do these kinds of projects? Or do I have bad records with police, or I don't know? Is our organization fit? Financial assessment, is our organization in fitness, and so on. Insurance. There is a lot of things. Technical assessment. They look into every detail. How do we ensure that the spacecraft, if it's not used or damaged, that it stops transmitting? Cyber assessment. Is your ground station secure? Can nobody hack your ground station? Ofcom review, export control, and so on and so on. And you see that that takes a while. So we already started last year, but in May we got into the details, and finally in November we still waiting for it, but we wait for the grant license to actually launch from Saxaford. So yes, we can. Size matters, and we want more. So maybe another Erminas mission proposal is underway. We are building up our ground station in Bochum by adding more antennas, especially for LEO satellites. We had another mission in proposal. Time is too short to go to this. We planned for Artemis 2. We hope for Artemis 3, a CubeSat demonstrator for deep space communication, also by using the Bochum 20-meter antenna, indeed, if we go behind the moon. We are working with University of Bochum on some CubeSats, some of those flat. You might remember this kind of design from the Swarm satellites I tested a while ago. Unfortunately, their service ends in December 24, but there are still a few things to be learned, and they have a very interesting concept of their quarter U design. So we want to upscale that so that we can fly first on the quarter 1U, that we could reflow some of our pocket cube PCBs, and even to a 1/4 4U, where we can actually have more in it. Okay, so I'm at the end. I can control a satellite from home. That's true. That's a while ago. But now we look forward what brings the future. So that ends my presentation. Thank you very much. And if you have questions, I'm happy to answer them.
Well, thank you very much, Peter. And it's been absolutely fascinating. And I've got a bunch of folk here, all absolutely gagging to have a go on your 20-meter dish. Or maybe they can try and see if they can figure out they can build a 20-meter dish in their own back gardens. So anyway, yes, thank you so much. We have a little time for some questions. Anybody? Yay, there's a few hands gone up. So here we come, Peter.
Hello, thank you for presentation. Given the size of these pocket cubes and open source design, how feasible it would be for individuals to actually build a tabletop model with a real thing, maybe with less expensive components?
I don't understand it. I'm not sure if I got your question right. So your question was if individuals could build something like this or
Yes.
rebuild their own pocket cube.
Yes, if they could build their own hardware and then submit it to you for launch. No? Oh, just on the tabletop, just to play for it. Yeah, okay.
Yeah. Okay. So in principle, yes, but unfortunately, there is indeed not so much room on such a pocket cube. So I try to figure out how to get back to that picture, this overview. So yeah, there was one board left here, the sensor board. That is the one we added. So in the original Cubics design, they have some masses there to increase the mass of the pocket cube. So if your pocket cube is more heavier, you have a longer lifetime. If it's lighter, so they had some masses added. We removed that and put our sensor board in. Indeed, instead of a sensor board, it could be possible to have some other kinds of interesting boards there, maybe camera processor or some other thought. So definitely this is a standard design. So all the boards have this kind of interconnector. They use I2C. So definitely it's possible to actually, instead of the sensor board, to have your own board here. That is definitely possible.
Thank you, Peter. This is Graham, VZV. Great presentation as always, so thank you very much for that. I've got two questions. You may decline to answer one or either of them or both of them. First question is, are you able to tell us at all about what actually happened during the test at Saxoford? And the second question is, you've got experience now of dealing with UK regulatory authorities. You've obviously got previous experience of dealing with other national regulatory authorities. How would you say the UK experience, how does it compare? Thank you.
Mm-hmm. So first of all, yeah, this hot fire static test, which, well, ended in the fireworks. Actually, all what I have here on that page is not NDA. So already in the next days, Rocket Factory Augsburg gave some first hints what might have happened. They even had a further analysis published later on. Indeed, at the moment, they are still analyzing. So what so far is known that there was a problem. Actually, the problem was not in the engines or something like that. There is probably it's not a design problem what they found out, but maybe some materials were not within the expected spec. So something was broken there. I think they have learned already a lot. They are still doing fault analysis, qualifications. They already have a new stage. Actually, we will fly what was supposed to be the second flight. So the first stage from the second flight will be used now for our flight. They have already done a lot of improvements regarding the launch. Yeah, somewhere in summer next year is what we expect. But as I said, they have to concentrate now on the qualification, on the analysis. So there's not much to say about in detail. That we have to wait from them. But as I said, they have been very open on that. That was actually nice to see and very different to what we usually see with the traditional big companies. So regarding your questions with CAA, what should I say? If I would have known before how much work I will be confronted with and how many questions, I don't know if I would do it again. On the other hand, okay, now since I have done it, I got a lot of knowledge, what kind of questions, and sometimes it's really like boring, and you ask yourself, why in the hell do they want to know this? What is their interest? But at the end, it's easier to scope with it and just give them the information they are looking for. Honestly, and we have a very good, really excellent relation. We have every Monday, we have our teleconference, and it's very nice people, and it's really good talks that I have to say. And for them, it's also a learning lesson. And they already told us we are the first they worked with. And actually, we were the first. We were really speeding up. We were the first to get in touch with them and work on these issues. And they understand, okay, they might have to change some of the processes. So at the end, I can only say positive things. It is a lesson learned. It's a lot of work, but working with the people is fun, and even we learn a lot about it. And I hope that some of the things we got will help you also to go through all those details they ask for. So, yeah, it has to be done, and everyone is more careful also in terms of space debris mitigation and how to ensure that the spacecraft will not be a problem for others. In fact, that is a problem for a spacecraft as small as a pocket cube, because they have problems to track those little objects, and they are more concerned launching them into higher orbit than into lower orbit. So because, let's say, in 400, 500 kilometers, they can collide with other objects. And they say, okay, why should someone else try to avoid to collide with you? So you also have the obligation to do everything. So in-orbit propulsion, orbit change, these are the things which will become more and more important in future.
Very good. Thank you very much, Peter. That's a very concise and comprehensive answer.
Yeah.
So, any more questions for Peter? Nope. Okay. Well, thank you so much, Peter, for your contribution. It's been a really marvelous presentation. We're now going to break for lunch, and thank you so much for joining us. And a round of applause for Peter, please.
Yeah. Thank you very much. And I enjoy your lunch, and later on enjoy the spaceship launch.
Yes, we're very much looking forward to that. We hope it'll happen. Okay.
I will too.
For now, Peter.
Thank you. See you next time.